Hello everyone, welcome back. My name is Zian Qing. I'm the main instructor of this MOOC. Today we are going to do something a bit different. Instead of a lecture, we have invited industry expert from Alfen to share his insights about battery management system. For that, I have prepared a list of questions which we collected from the learner. Thank you, Shomia, for coming and joining us. First of all, maybe you can give a short introduction about yourself, your company, and your role there.
Yes, thank you, Shen. So my name is Shomo Bantopadhyay. I've been working in Alfen for 3 years. A bit of a background, I studied here in Delft in my PhD and master's in power electronics. Now I've been working in the industry for almost 6 years now. First 3 years in an automotive industry, and then for the last 3 years in Alpha. My role in Alpha is basically charting the future of the products we have in energy storage. And there we have two types of products. One is stationary energy storage, more for bigger applications, for energy trading, peak shifting, and mobile battery storage for more granular applications like events, basically achieving net zero. And that's also what Alfen's vision is for Europe.
Okay, good. Maybe let's first start with this question regarding the battery chemistry. I would say maybe 10 years ago and before that, we were talking about NMC for kind of high power applications, right? But in past years, there is also LFP coming into play, which is claimed to have a higher, longer lifetime, a higher reliability, safety, etc. But recently, there is also sodium-ion batteries. So from your perspective, what is their position in industry applications so far?
Yeah, interesting question. You're right that NMC has always dominated the discussion, especially if you see in US and Europe, because there's a lot of legacy NMC applications. So you still see in US and Europe that the amount of applications using NMC is still high, but we see the trend that it's going towards LFP. And one of the reasons LFP is so strong is basically, as you said, but also the cost. Because if you look at the price of pack, which is 81 euros per kilowatt hour for LFP, compared to NMC, which is 120 euros per kilowatt hour.
That's a big difference.
That's a huge difference.
Yeah.
And China is kind of the leader in this LFP business, especially with prismatic cells. And we see in China it's already more than 80 to 90% LFP. Europe is somewhere, I think the inflection point has already happened, so it's mostly LFP. In USA, it's still pretty slowly going towards it, but I would say that it's currently about 80% NMC, 20% LFP.
Okay. And how about sodium-ion batteries?
Yeah, interesting. So I think this is a very interesting one because sodium-ion batteries have, from a material perspective, a lower floor compared to LFP. So basically what it means is if you can get economics of scale, it can be actually cheaper than...
Indeed.
And sodium-ion has very interesting advantages. Like, for example, the thermal safety is much better, right? You can ship the batteries at 0 volt as well. You don't need to do that. Your application or degradation or performance degradation is not there for a huge temperature.
No.
So therefore, it makes it very interesting, but it really has to improve on the specific power density and volumetric power density.
Yeah.
Until that happens, and even then it happens, I think sodium-ion is not going to replace LFP anytime soon, depending on the applications. For example, in EVs, I think sodium-ion is already kind of capturing the lighter weight scooters and smaller cars. It will stay there. In base application, if there are already applications coming in, new companies coming in, especially in the CNI market, and especially in those CNI markets where safety is really very important, like hospitals and other energy secure places. So it's coming, but I don't see it replacing LFP in the next 10 years. But it will create a niche for itself.
Because generally sodium is much heavier than lithium, right? So I can imagine that for stationary energy storage, where weight is not so sensitive indicator, it should be more suitable for sodium-ion batteries.
Yeah, true. But cost is also another factor. Because if something is bigger, you need bigger passive components as well. Footprint is a big issue when it comes to stationary storage because land is expensive.
That's true, especially in Netherlands.
Exactly. And then your footprint efficiency of the battery is also very important.
Okay, okay. Then let's move on to the next question. Because this course is about battery management system, so we have a few questions regarding the challenges of BMS development. First is about the SOC estimation. The traditional approach like ampere counting and the OCV lookup table, I believe they are very widely used in industry, right? But recently, the people also developed advanced approaches like Kalman filter-based or model-based approaches. Do you see this kind of new approaches also becoming popular?
They're already popular.
Okay.
If you see the market in both EV industries and stationary base as well, I think we are already seeing that there are two forks in the road, I will say. One is fully data driven because now we have so much data being generated.
Exactly.
On every side across the all assets. So you can do something with the data. There are big companies like Twice, Accure, and there are also companies who are doing the model-based approach as well. From our experience, what we see is the best approach looks like which combines all the approaches, the ensemble approach. So where certain companies who are using the physics-based model, combining that with edge computing,
Yes.
and doing the long horizon optimization on the cloud analytics,
Yes.
and creating the best of all the worlds together,
Yeah.
it looks like this is where the future is going.
Okay. But how do you consider the computation resource? Because let's see, for these more advanced approaches, you need a bit more, or maybe sometimes significant more computation resource, right?
Absolutely.
That also means some more extra cost.
Yeah.
How do you see that?
Yeah, so that's the very interesting thing, right? Something which incurs cost has to create some value at the end of the day.
That's true.
And the value is coming differently from different industries,
Yes.
right? Like, for example, if you look at the EV sector, where range is such a premium metric, right? Because we still talk about electric vehicles not having enough range as IC engines. So if you can create a vehicle with 1,000 kilometers range, you will sell a lot effectively. So when these kind of incentives are there, the need for this kind of slightly higher cost, but you get what you are paying for it are there. Same in the stationary base as well.
Okay.
The reason being, till now, stationary based revenue streams were coming from ancillary markets, which were more power based. So there was no push to get your SOC accuracies higher.
Okay.
As long as you can deliver power from the battery,
Yeah.
you're making money.
Well, that's good.
But in the last few years, ancillary services have saturated, and more money is to be made in the wholesale markets, which are energy.
Yeah.
So energy estimation or state of energy estimation has become very crucial.
Okay.
And therefore, the SOC inaccuracies and therefore the SOE inaccuracies leading to from that has become kind of like a bottleneck for revenues.
Okay.
So that is kind of also pushing that, okay, we don't mind paying a bit more expensive BMS if you can increase our usable energy accuracy.
Okay. That's very good to know.
Yeah.
Then for the SOH estimation, and by the way, SOH is short of state of health. There is a promising approach so-called EIS-based, right? EIS is electrochemical impedance spectroscopy. So my question is the onboard EIS being considered for real-time agent monitoring already? Recently, there is a company already launched the IC, which can do onboard EIS measurement. But is this, do you see that this approach is going to be widely adopted very soon?
Define very soon. As I said, right, I think the drivers to go towards there exists. And because EIS till have been a laboratory method, right, which is expensive,
Mostly, yes.
offline,
Yeah.
and there is value for EIS. One of the, not only SOH, but I think even more important is the temperature.
Okay.
Because this have been one of the most critical, because temperature is such a crucial metric for the
Yes.
aging, right?
Yes.
SOH is a derived factor from that. And therefore, if you can really get an idea of the internal temperature of the battery, the same you do with transistors, right? You use this kind of models to understand the junction temperature.
That's true. That's true. Yeah.
EIS has a lot of potential there.
Okay.
My understanding is you will see this very soon in the EV industry, especially in the luxury segment. In the stationary base, I am skeptical that you will see it in the next 5 years.
Okay.
But it will. So basically, what happens in the EV industry today happens in the stationary base.
Yeah, it's true.
2 years down the line or 3 years down the line.
Yeah.
Because the incentives are very similar.
Yeah. I can imagine. So then for the second life batteries, because let's see, battery is still a component which has a relatively shorter lifetime than most of other components. That means today we have a lot of secondary life, let's say used batteries, right? If you want to use it again, then they become a second life battery. Do you see? Maybe first of all, can you give some successful examples about the second life battery used in industry? And then what is the biggest hurdle, to have them widely used in industry from your point of view?
Yeah, good question. I think there are already very interesting examples where there are commercial applications using second life battery. One is in Redwood Energy. They have made a site, I think, around 80 megawatt hour using second life electric vehicle batteries. There are companies like Acute, Zenobo, who are using second life batteries from EVs to create CNI energy storage applications.
Okay.
From my point of view, I'm still a bit skeptical because the extremely high-paced falling prices of LFP is something which kind of deters the second life battery sources. Because really using an EV battery, because normally in second life applications, the second life application has to be much less strenuous than the first application.
That's true.
So effectively, you use an EV battery, take it in industrial to CNI to residential. So I think the most critical application or the most attractive application is actually the residential, because it's the least amount of strain you put in the battery.
I agree.
But the higher you go, so CNI, industrial, automotive, the less the use.
Yes. But how about the safety? I mean, for the residential applications, safety is still maybe one of the most important indicators.
Yeah.
So how do you see this?
So I think this is a gray zone, in my opinion, because really safety-wise, you need to do a lot of testing when you're taking the IC, you're changing the pack. Basically, one of the biggest problems when you take an electric vehicle is that basically you have a lot of connections in series and parallel, and maybe one cell is just determining the age of the pack.
Yes.
But from EV point of view, they have just discarded it, put a new one. Maybe you can just take that bad cell out and reuse a lot of it. So there's a lot of value to go in the pack and get it out.
That's
but
true.
This whole process of, okay, this is discarded, this is reused, this is still a bit of in a flux and not standardized well. But things like battery passport will help this kind of things. And then therefore aid the circular economy. I think it is coming, but at this point of time, the falling prices of LFP doesn't still make a very good business case. That's my point of view.
Okay. Good that you mentioned a battery passport. That's our next question, actually.
Nice.
Let's take a bit of the rest time to talk about the future of the battery management system. First question is, we already touched a little bit about these questions, but still, how do you see the potential of integrating this, let's see, artificial intelligence, machine learning with battery management system, right? We're talking about how it is going to be used for, let's see, SOC. There we touched a bit about advanced approach, right? But generally, how do you see the potential of using this, artificial intelligence, machine learning for battery management system? First question.
Yeah. All right. I think very much so, because it's already there. Actually, there are multiple high tier level companies who are using AI based approaches, because ultimately what AI needs, it needs good high fidelity data.
That's true. Yeah.
And most good system integrators have them.
Yes.
And if you see the amount of batteries being now operated, so you can imagine there are billions and billions of data points generated every day, every hour. So there's a wealth of data which are already there, and companies are doing that. Sometimes they're using brute force, but what that means, they are just using a data, do not care about the physics of the system or the non-linearities in a battery system. That's one approach. but I think the most successful ones were combining the model-based approaches and using real-time digital twinning, where they're streaming the data. This is where the future lies. And then changing the parameters of the model. It can be a simple like Thevenin equivalent circuit of individual cells, right? And you just update the DCR and everything based on the streaming digital twin you have in the cloud. And this is already happening. A lot of battery analytics companies are doing that on a high level. So I mean on an asset level. But also there are companies who are doing it on the more granular level as well. I think the future is basically AI cloud computing based with edge, some aspects of edge computing as well. So basically finding the right balance between these two is the crucial part.
That's true.
And my bet would be bet on companies who combine physics-based models with data. That's the best way to go.
That's good. You also mentioned, let's see, this artificial intelligence approach. A fundamental thing for this is some very good data, right? With very good accuracy, very high accuracy, and also very well recorded through its operational lifetime, right? So then it touched two questions. One is about the data transparency. Another is touching about data privacy, right? For instance, you buy a battery from a manufacturer, then they have expertise to process the data, and also they have the motivation to improve their battery performance, right? But the user actually has the data. They have the ownership of the data. So then, is it going to be 100% share about the data from the user to the manufacturer? Sometimes it's not simple like this, right? So there's always data transparency and data privacy issue or balance between them. Then recently, EU has launched this battery passport, right? I mean, of course, there are a lot of details, but I would say one of the major challenges it is trying to solve is, make sure battery always have a very good data record, right? And it should also solve the balance between the data privacy and data transparency.
And security.
And security, yes. Since you are working in industry, you may be more sensitive about how this battery passport is, really deployed there in industrial applications. Maybe you can share some insights on this battery passport.
Yeah, it's a big topic, so it's really hard to summarize this, but let's give it a try. Right? I think battery passport is very interesting in that direction to really make sure. So basically, if you look at the battery passport, you have two types of data. You have the static data and you have the dynamic data. So static data is basically coming from the manufacturers, right? So they're giving it, if they're giving it tick, 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 you self-report, we have this. That's it, not much to do. I think the crucial part, and also maybe this is where many companies can differentiate, is how you store and manage the dynamic data. And I see this as a good thing, but also a risky thing, because this also this puts a lot of burden on the SMEs, so the small and medium-sized companies who are in this business, and it will really favor the big ones.
Yeah, that's true.
Who really? So I think there are good things, because if you do that, that's very good, because it kind of makes sure that you have ethical sourcing and also the right history of what has gone through to this battery. That makes it much sure, let's say 10 years down the line, you can actually have a second life use case and with a lot of high fidelity data backing up the safety. That will save you a lot of time in doing a lot of expensive testing to kind of re-verify the data. Okay, is the SOH really 80%? Or is it just showing a number? So these kind of things are going to be very good on the term. Security is something I still think about, because it's not so clear that, because there's a balance between anybody who can go to a container, scan a QR code and get the data. But how much data that should be?
It's
so
difficult.
This balance, I think, is going to be struck by the industry, because going through the battery passport, this demarcation is still not there. And I don't know whether there's a good answer to this, but I think there's enough leeway given to the OEM manufacturers to find the right balance between data security and accessibility, because two things are to a certain extent mutually conflicting.
That's true. Okay, thank you very much, Shoni.
Thank you, Shyam.